In the next few lectures, we're going to teach you about machine learning. Machine learning is a super exciting direction. It's powering some of the greatest breakthroughs in technology. So what is machine learning? It's where instead of programming the computer in a particular way, telling the computer how to handle every possible situation, instead you show the computer some examples and it learns how to handle those situations. As I mentioned, machine learning is having an enormous impact, and you may be using technologies that are using machine learning without realizing it. For instance, if you use Google Translate or machine translation, that was built using machine learning. The way that works is Google compiled a large data set of, for example, sentences in German and then their translation to English. And given enough examples and the right algorithm, the computer is able to learn to translate from German to English. Or if you've ever talked to your computer and used speech recognition, maybe you use Hey Siri or OK Google, and it recognizes what you're saying, speech recognition also made possible by machine learning. The way that works is you train the speech recognition system by collecting a large data set of the sound, what it sounds like for someone to say something, and what the corresponding text is, and the computer is able to spot patterns given enough data and work out how to recognize speech. And if you followed advances in self-driving cars, super cool stuff. I want one. Partly being made possible by machine learning, where instead of trying to write down a program to describe how the car should drive in every possible situation, instead you show it examples of how to handle different situations, and the machine learning algorithm learns how to drive the car. Very cool, very powerful, definitely worth knowing about. And in this class, we're going to teach you about a particular kind of machine learning technique called classification. And a classifier is a machine learning algorithm that's used to answer yes or no questions, usually. So a classifier makes predictions based on historical data, given some data set showing some situations in the past and what the right answer to the question was. It looks for patterns that'll help it answer that question in the future. Okay? So for example, if your bank might be using a classifier to decide whether you're a good credit risk based on a data set of people they've made loans to in the past and who paid them back and who went bankrupt, they can then look for some patterns that'll help them decide when the next person requests a bank loan, whether or not they're good credit risk. Another example would be advertisers use classifiers to decide, if I show the person this advertisement, are they likely to click on it? Are they likely to buy? What if I show them that other advertisement? Okay, so that's classification. I think maybe it's easiest to understand classification by talking about some examples where classifiers are used in industry. One example is many merchants use machine learning to try to predict which transactions will be fraudulent and which are legitimate. When you make a purchase on Amazon, they're trying to make a prediction. They have to know, is that really you? Is this a legitimate transaction? Or is this fraud? Has someone maybe stolen your credit card number? And they have a classifier that's designed to answer that yes or no question. Fraud or legitimate. It works by looking at historical data. They've got lots and lots of historical data about past transactions, and they know which ones turned out to be fraudulent, which ones turned out to be legitimate. So then they can use that data set to look for patterns that are indicators of fraudulent transactions. And that's what the classifier does. It learns how to recognize which transactions are fraudulent, which are legitimate. And you can imagine how that might work. It probably looks at different attributes of the transaction. Like, for instance, what's the amount of the transaction? Is this a small or a large value thing? What are you buying? If you're buying diamonds, maybe that's a higher fraud risk than if you're buying a book. Where is it being shipped to? Is it being shipped to your billing address on file with your credit card, or is it being shipped to some new address you've never shipped to before? Okay, so for example, the classifier might be using these kinds of properties of the transaction, we call them attributes. And we know in the historical data set what those attributes were for each historical transaction, whether it turned out to be fraudulent or not, and then can figure out from the historical data which ones are most predictive and use that to make a prediction about each next transaction that Amazon sees. This is used all over online commerce. It's not limited to just commerce. It's used all over the place. There's some very cool applications of machine learning and classification. For instance, one that I found really neat was researchers have recently worked out how to take an image, a picture of a growth on your skin, and use that to predict whether or not it's cancerous or not. Normally you'd go see a dermatologist, and the dermatologist takes a look at it and they use their experience to predict whether or not you should be worried. Well, researchers have figured out how to use classification to use different attributes of that growth on your skin to automatically predict that. Wouldn't that be cool? You don't have to make a doctor's visit. You can just take a picture with your phone and it'll give you its prediction. And these predictions aren't perfect. The doctors don't always get it right, and the classifier doesn't always get it right, but it's right more often than not. Does this mean that your phone is going to replace a doctor? Probably not, because there's a lot of things a classifier can't do. Like when you go see your doctor will take medical history and knows what tests to order, and there's a whole set of experience that's not captured just in that one yes or no question. Given this picture, is that growth likely to be cancerous or not? But it's pretty neat that the research has advanced far enough that classifiers can predict as well as trained doctors. There's another example that I find fascinating. Classifiers are used in online dating sites to help predict if we match you up with this other person, will the date go well? Will you hit it off? You can imagine they have a lot of data about past matches and which ones worked out and which ones didn't, and that'd be useful for making future predictions. And I found it especially fun because I ran across an example of a software engineer who reverse engineered how the machine learning algorithm was working and used it to up his chances of finding a match. So he had a profile on OkCupid, and he wasn't getting many responses from women. So he worked out how to game the system. The way the system worked was the site would ask you questions, and you could enter your answers, and it would try to match you up with other people who answered similarly. And importantly, you could mark which questions were most important to you. Like if it was really important to find someone with the same religion, you could mark the religion question is really important. Or if that wasn't important to you, you could mark it as unimportant. So what this guy did was he gathered data on the profiles of all the women in his area and figured out which questions to mark as important to maximize the number of matches he got. And then proceeded to end up with a ton of matches, went on a ton of dates. Fun story. I like it because it shows how if we use machine learning, and sometimes it might enable people to game the system and work out how to fool the machine learning algorithm. Funny story, the interview that I read with him at the time that he was interviewed, turned out the woman he was currently with, he'd met not through an online dating site at all, but through his social network, his friends. Okay, so classifiers are used all over. We're going to teach you a little bit about classifiers, and one of the reasons we're teaching this is because we think this is really useful and powerful technology for you to know about. It's enabling a new kind of programming. Instead of programming a computer by working out a rule for what the computer should do in every possible situation and then implementing that in Python or something like that, instead, the machine learning approach is that you gather a lot of examples. You gather a large data set of situations that have come up in the past and what the right thing to do in each of those was. And then you teach the computer by example. And you use a classifier algorithm to help the computer learn what the right thing to do in the future is. I guess there's a powerful new way of programming that enables the computer to learn what the right thing to do is, even when we're not sure how to write down a rule that would cover all the cases. There's another reason why I think it's useful for you to know something about classification, and that's that as machine learning starts to get used throughout our society in a variety of ways, it's going to have some interesting societal implications. And to be a good educated citizen, I think it's helpful to know a little bit so that you can understand what those implications are. And one of the ways that machine learning has some interesting implications is it has implications for fairness and discrimination. For instance, one place where machine learning is already being used here in the US is to help judges, when they're sentencing criminals, decide whether or not to give the criminal parole and how long a sentence to give them before they're eligible for parole. And they use a program that has a machine learning algorithm that tries to predict if we let this person out on parole, are they likely to commit another crime? And that works by looking at past historical data and some attributes of the person. Well, interesting and useful application. Some people are criticizing this as potentially discriminatory, that it may be discriminating against blacks. And you can imagine how that might happen. What's surprising, you can imagine how that might happen, for instance, if blacks have tended to have a higher rate of crime, then a machine learning algorithm that's given access to the race of the person might well learn to predict that you shouldn't give parole to blacks, which would be unfair and racist and totally discriminatory. What's maybe surprising is that can happen even if the computer isn't allowed to know the race of the person. It's kind of surprising, but it turns out there are other attributes of people that are correlated to race and that might end up allowing the system to, in effect, discriminate by proxy. For instance, characteristics like the size of your family, whether anyone else in your family has been convicted of a crime, are your parents divorced or not. Those are mildly correlated to race, and a system could easily end up learning some pattern that is, in effect, discriminates by race. So there are some serious questions about how to ensure fairness and equity when we use machine learning. Our machine learning systems can, there's sometimes some people have a belief that if it's a computer making the decision, that it'll be free of any kind of human bias. But what can actually surprisingly happen is that when you train a machine learning model on data that comes out of a human system with bias, then the machine can end up learning that same bias and mirroring the human bias that's historically been present. So this can raise a lot of issues. I'm not going to talk about them anymore in this class. Instead, I'm going to focus for the next few videos on teaching you a little bit of an introduction to how classifiers work. It's a really deep subject. You could take entire courses on the topic of machine learning and classification. I can't teach you all of that, but I'm going to teach you just the basics. So I hope I've whetted your appetite for what's to come.